Okay, so let's have a look at methods of sampling. And you're expected in quiz 6B. 5B is going to ask you about these. You'll be given an example of a kind of sampling. And then you have to work out what kind of sampling it is, what the disadvantages are, and what the advantages are. Now, there are some notes on Blackboard to do with that. And as well as that, just about any statistics book in the universe will have this. And the other thing is Wikipedia does. This is why I didn't get you to buy a textbook, apart from the fact that you probably would like not having to buy a textbook, is that statistical knowledge is so easy to get hold of. Basically, find a textbook. There are hundreds of them in the library. What happens is every year somebody chooses a different textbook and they get left at the library. And find one that suits you if you find that these notes are not sufficient. Okay, so the first one, convenience sample. This is where I go, okay, I'm going to ask you 5 people here because you're closest to me and I'm just going to ask you, and that's real easy. That's a convenience sample. Or if you stand in a shopping mall and say, oh, does anybody want to come and answer this questionnaire, and people walk up and answer it. That's convenience. It's also called self-selected, and it can be a real issue. So basically, convenience is just grabbing whatever data you can do. And if ever you did a little example at school where you had to do a little survey on what you did, has anyone done little surveys at school like that? Or in any other subject? The chances are you probably used a convenience sample. You probably went home, asked your mother, your father, your brother, your sister, your 3 best friends, your aunt, your grandmother, and the next door neighbour, because they were the only 10 people that you could find easily, and that was a convenience sample. And its validity is seriously compromised. Okay, the next one. So that's fairly dodgy. Simple random is in fact really, really not simple. Simple random means that every single person or object has an equal chance of being chosen. So if I want to do a simple random sample of 100 people from the New Zealand population, what I would do is I would get all of the electoral rolls, and so already I've got to limit it to all of the people who are on the electoral rolls, and then I say, right, I'm going to number them all from 1 to 3 million or whatever, and then I'm going to get 100 random numbers, and then I'm going to look up those random numbers to see who those people are, and then I'm going to ask them. And I've got one of them's in Invercargill, I've got 5 in Auckland, I've got 1 over in the Chathams, I've got 3 in Wellington, and so you can imagine it's not simple. It's really, really difficult. The people might not be there. It's really expensive. So very, very seldom is simple random sampling used when it involves people or anything other than scientific, chemical or biological experiments. And this is one of the reasons why we have this course separate from the other statistics course, because a lot of their stuff aims at biology. If you're growing plants, you can have a big bowl of seeds and randomly take 100 and they will be random. But you can't do that with people. So simple random sampling, in its true sense, is very, very difficult to achieve. Okay, so often what we do instead is we do systematic sampling. So we just take every 5th person or every 10th person or something like that. Or we might take the 28th person on each electoral roll or something like that. So that's called systematic sampling. And it can have problems as well. You have to stop and think about what things might cause this sample to be further from random than it needs to be. So because ideally we want things to be as close to random as possible. So this is the ideal. So when we do something else, we have to stop and think, okay, what could be happening here that stops it being ideal? Now, a really weird one is that, say you're trying to measure logs that are going past you on a conveyor belt, and you say, I'm going to check what log is going past every minute. Okay, now the problem is if you do that, longer logs take longer to go past, so there is a greater probability that you will actually check the longer logs because they're more likely to be going past at any one point in time. So something that seems like a systematic way to do it actually ends up biasing your sample. Okay, now stratified means that you partition the population, so you decide, okay, I think in this class older students and younger students probably have different behaviours. So I'm going to make sure, now 30% of the class is older and 70% is younger, so I'm going to make sure that I take 30% of my sample from the older students and 70% from the younger students. And that's called stratified sampling, and it's a very effective way of getting a much better result, or a much more informative result, without having to sample too many. Now, cluster is different again, where you divide the population into sectors and then randomly select a few of them and choose all of the members in them. So that's different from stratified. Stratified is where you have different partitions which are due to a meaningful one, and you choose randomly within them, whereas cluster sampling is where you actually go for whole things. Now, when I did my PhD, I went to 20 different schools in New Zealand, and within those schools I went to 3 different classes, a year 9, well maybe it was 6. God, it was a while. 6 different classes, whatever. But there was 2 year 9s, 2 year 10s and 2 year 11s. And that's how I got my data. That was cluster sampling. Within each class I asked every child in the class. If I was going to go for random students throughout New Zealand, it would be very, very difficult to achieve.